Okay, let's talk about pressure measurements. Now, this is what is called a gauge pressure. This measures gauge pressure. Again, pressure is defined about the amount of force divided by the surface area. So pressure is how much force you have acting per area. So here you see kilopascals as some of the units. Some of the other units are PSI. Atmospheric pressure is roughly 10 to the fifth pascals, or about, I hope I'm getting this right, 14 PSI, which is pounds per square inch. I think that's correct. Okay, so roughly, PSI is a bigger unit. Okay, not quite 10,000 times bigger, but it's a few thousand times bigger of a unit. Now, again, where does pressure come from? Pressure comes from the weight, of all the atmosphere pushing down. Now, up in the thermosphere, there's hardly any gas at all. So that doesn't contribute very much to weight. That doesn't contribute very much to the atmospheric pressure. If you look at this right here, the atmospheric pressure in the thermosphere is pretty close to zero. You die there very quickly. Even in the mesosphere, okay, not a lot of density there, not a lot of weight. It's not until we get to the stratosphere that we get to any appreciable atmosphere at all. But even the stratosphere only makes up about 20% of the total weight of the atmosphere. It's a troposphere where we have most of the density, most of the mass, and you guessed it, the greatest pressure. Okay? So what we see as atmospheric pressure is the combined weight of all the gas above us. Okay? The higher you go, the less air you have above you, and then you have less pressure, of course. Now, I'm not going to go through this, but for all of you calculus whizzes out there, here is an equation that shows you how you may derive the atmospheric pressure as a function of height. Again, let's go back here. We look at this, and this looks very much like, almost an exponential function. Okay, has that look to it. Well, that's no surprise, because this right here is the pressure as a function of y, which is the altitude. And you can see some other things that come into play. Temperature is a factor, gravity is a factor, and the mass of the gas is also a factor. How do we get that? Well, it comes from this equation right here. The change in pressure is equal to the infinitesimal amount of weight divided by volume. Okay, so that's where it comes from. And if you integrate both sides, you then get this lovely expression right here. That would work well if the atmosphere were, one temperature, and it's not. Different parts of the atmosphere are different temperatures. Of course, the troposphere tends to be slightly warmer. Then we get up into the higher parts of the troposphere where the temperature drops and it increases again as we go from the stratosphere to the mesosphere. Then it decreases, then it increases. So it's a little more complicated than just the way we modeled with that little differential equation. All right, measuring pressure. We can measure pressure so many different ways. All we really need to do is have something that can act as a force sensor. Springs are great force sensors because they obey Hooke's law, F equals negative kx. The amount that they change their displacement is proportional to the amount of force that you put on them. And of course, Pressure is force divided by area. So springs make really good devices for creating a pressure gauge, okay? They're also, you can use other things like piezo crystals. Oh, what else? Thermocouples are actually used. I never quite understood how they were used, but anything that can measure force. Oh, I'm going the wrong way. Here's a Borden tube, which is a really simple but a very nice way to create a pressure gauge. And you can see here we have the tube, which we put air into. And as the air fills this tube, it almost acts like a balloon, and it expands. And this causes it to pull on a set of gears, which then rotate a pointer. Yes, we talked about the variation of pressure with depth, fluids at rest in the container, all portions of the fluid are in static equilibrium. Otherwise, the fluid would not be in equilibrium. So let's say you're measuring your tire pressure and your tires read 0. Well, technically, the total pressure of the tire is not 0. It's just become atmospheric pressure. Gauge pressure is the atmospheric pressure, I should say, the additional pressure minus the atmospheric pressure. Okay, that's gauge pressure. So like when you measure the pressure in your tire, you're really measuring how much above atmospheric pressure you are. Because if your tire is at atmospheric pressure, you have a flat. If you're at 32 pounds per square inch, well, its gauge pressure is almost 2 atmospheres. Its absolute pressure is about 3 atmospheres. A manometer is a typical device that we use to measure pressure. It actually uses the weight of mercury, okay? Here we have some source of pressure pushing down on a column of mercury, and that will push the mercury to a particular height where the pressure exerted will be equal to the weight of the mercury divided by the cross-sectional area of the tube, okay? Very, very simple. Why do we use mercury? We don't like to use toxic materials, but mercury is a very dense liquid, so we don't have to make the height too high to measure a nice range of pressures. The first barometer, which was used to measure pressure, atmospheric pressure, was a column of mercury. And again, we can imagine the atmospheric pressure pushing down here, and it's going to have to support a certain weight of mercury. The top of the mercury has a vacuum, by the way, so there's nothing pushing down on it. And you'll sometimes see atmospheric pressure, measured in millimeters of mercury. It literally means what you think it means. How high of a mercury column in millimeters can this atmospheric pressure support? There's a high pressure system, the mercury level goes up. There's a low pressure system, there's less pressure to support that much weight. The tube goes down. Blood pressure. We try to monitor our health by looking at blood pressure. Heart disease is the #1 killer in the United States, even though COVID's giving it its run for the money. Pressure is typically measured, again, in millimeters of mercury. And for a normal human being, you want to have a pressure. You've diastolic, which is the low pressure, and systolic, which is the high pressure. Your low pressure, you want to be from 60 to 79. Your higher pressure, 90, but not higher than 119. Now, recently, the Heart Association has define a new category called pre-hypertension. That's pre-high blood pressure is what it means. If your diastolic is 80 to 89, your systolic is 120 to 139. Anything above that is considered to be high blood pressure and puts you at risk for heart disease. Stage 1 hypertension, 90 to 99, 140 to 159. Stage 2, 100 to 109, and 160 to 179. If you're over 110 diastolic, won't switch for me, over 110 for diastolic and over 180 for systolic, you are experiencing a medical emergency. That's more than high enough to cause a stroke. So again, there are different units of pressure that you'll see. We are used to using SI units, so pascals are our favorite unit, okay? But again, pounds per square inch is a common British unit or US customary unit. And 1 atmosphere, again, is about 14.7 pounds per square inch. And again, you typically have about 30 some pounds per square inch in regular automobile tires. Truck tires will have higher pressure. So again, you can see there's roughly 2 atmospheres above atmospheric pressure in them. And again, we can measure millimeters of mercury or centimeters of mercury. They're pretty interchangeable. All right.